Now, when we talk about enantiomers, we have to first discuss chirality. Now, what does that mean? Well, a chiral object is defined as any object which is not superimposable with its mirror image. While an achiral object is defined as any object which is superimposable with its mirror image. So what are some examples of this? Now let's say you have your left hand here. You pretend you have a mirror going to the right of it. You'll notice that the mirror image of your left hand would simply be your right hand. And you'll also notice that your left hand is not superimposable on top of your right hand. Therefore, since your hand is not superimposable on its mirror image, it must be chiral. Now what about this pen? Let's say you have this pen here, and you have the mirror again going towards the right of it. The mirror image would simply be this. Now let's see if this object is superimposable on its mirror image. And you'll notice that it is. So therefore, this object must be achiral. Now chirality can also apply to molecules. Chiral molecules are defined as molecules which are not superimposable with their mirror images, and achiral molecules are defined as molecules which are superimposable with their mirror images. So how do we test for chirality in molecules? Well, the most commonly used test is known as the plane of symmetry test, in which if we do have a plane of symmetry in a molecule, it must be achiral, and if we don't have a plane of symmetry in a molecule, it must be chiral. So let's test this on ethane. Now the easiest way to find a plane of symmetry in this molecule is simply to cut it through the single bond. And you'll notice that both sides of the molecule are identical. Therefore, since we do have a plane of symmetry in this ethane, it must be achiral. Now what about this version of 2-bromobutane? Now, no matter how you orient this molecule, and no matter what way you try to cut it, you'll always find that you can't get a perfect plane of symmetry. Therefore, since you can't get a plane of symmetry in this molecule, it must be chiral. Now therefore, since this molecule is chiral, we can also have an enantiomer. Now enantiomers are defined as the non-superimposable mirror images of other molecules. Therefore, simply from the definition, all chiral molecules have enantiomers. So let's try to find the enantiomer of this molecule. So let's have this molecule here. Let's pretend we have the mirror to the right of it. So what would be the mirror image of that molecule? Well, it'd simply be this. And let's see if these two are superimposable on top of each other. And you notice that they can't. They are not superimposable on top of each other. Therefore, they must be different molecules, and in this case, they are enantiomers.